All right, so here's our results. My calcium carbonate, the chalk, both of them went up about 4 degrees. So no, that was not something that helped us to cool down the ice. The ones that looked like they had a decrease, calcium chloride, which is, who's got that one? Who did calcium chloride? What is calcium chloride? Okay, a type of salt. Citric acid went down quite a bit. Who had that one?
I did.
Which I was surprised at. I don't know if that's supposed to happen. We had another sodium chloride down here, went down quite a bit. Who had the sugar? Boraine, right? You got boraine one like chalk. But the sodium chloride did show quite a bit of movement. 10 degree change, 15 degree change. And it was as you guys predicted, right? You said, I think it's going to be the salt. And we got two different types of salt up here, and both of them cooled down the ice. I'm going to look back if citric acid is supposed to do that, or if there was maybe a miscalculation on that. We had talked about trying to keep the variables only having some items that were a variable and changed. What was difficult here? What do you think might be making this not a perfect experiment? Yeah.
We're not scientists.
No. You gotta give me more than that, because scientists could mess up something too and have there be error. What about you not being a scientist would cause you to do something that would not make the experiment go smoothly, or not give accurate results, I should say? Yeah. Anything as part of the process where you thought, that might have kind of skewed my results?
You may not have crushed the ice enough.
Okay, crushing the ice does have some effect, and I'll explain that later. One that I saw, I initially put my thermometers in here. I had it listed as -5 and -5 degrees. And then I pulled the thermometers out just to mix in the chalk. Did you notice a difference between when you did that and put the thermometer back in? Like it warmed up quite a bit quickly. I still listed my initial temperature at -5. But maybe you stirred it up, put the thermometer back in, and now it's a warmer thermometer, and you took that measurement. That could have been a little error there. Okay. But we are seeing that there's a couple substances that if you mix it with ice, it's going to cool it down. I mean, to get down to -10, -15 degrees, that's quite a difference, isn't it? And so we should be able to take a substance like sodium chloride, mix it in with the ice, and see if we can actually freeze the water. Okay? We're going to take a look at that tomorrow. Maybe not tomorrow because we have Spanish, but on Friday. So right now, we're going to take some time to get this stuff cleaned up. But then here's what we're going to do with the rest of the time remaining. Based on what you see here, I want you to figure out a design for a freezer. Okay? So here's the criterion. By the way, criterion is singular, criteria is plural. That's why it's criterion. The device has to freeze 10 milliliters of water in a plastic cup in 20 minutes. So the constraints are choose a white substance based on what you just picked. What do you think would be wise to pick? Use no more than 4 2 milliliter spoonfuls. And we stop the testing after 20 minutes. If that were to be what you're trying to set up and trying to do, freeze water in a room that doesn't have a freezer, how could you basically create a freezer to freeze this water based on what you now know? Okay, so after we're done cleaning up, I'm going to have you fill out this half sheet of paper that basically does this. You're going to draw an illustration, which will probably look kind of similar to this with some markings on it. And then you're going to write down how you would plan out to do this. Make sense? All right. Once we get things cleaned up, then I'll pass these out. Go for it.